Okay, so what we're going to go into is carbohydrate metabolism. And we're going to study a small part of it in detail. Now, what I want you to get out of this you're going to see today is what we are going to try to identify are the enzymes responsible for some of the steps. We always start with glucose, and then from glucose, we phosphorylate it. And once it's phosphorylated, it's then broken down into a, so these are all 6 carbons at the top, up here. And as it goes down, it's broken in half to a 3 carbon unit. And then once we convert it to that pyruvate, it's then goes down to that. Now, as you can see, from there, that's how we make lipids. From there, that's how we make proteins or metabolized. And then down here, we enter the Krebs cycle, which is, okay, so carbohydrate metabolism is in 3 parts. Down to acetyl-CoA is called glycolysis. That's what we're going to focus on today. Then the next step is Krebs cycle. Then the next step after that is the electron transport cycle. There are 3 parts. Okay. The Krebs cycle is also called the citric acid cycle. So it depends on what book you're looking at or whatever. They call it different things. It's basically the same thing. This is where carbon dioxide is kicked off, for example. Okay, so now we do everything with glucose. Everything with glucose, galactose, and fructose. But glucose is the main thing. Fructose comes in at the 3rd stage right here. And so does galactose. And then it proceeds on. This is what pyruvate looks like. And this is what acetyl-CoA looks like. Okay, so as you remember from our carb unit, glycogen is the only carbohydrate that mammals produce. And it's stored in 2 places, the liver and the muscles. Now, there's a lot of extra stuff here that we're not going to get into. The main thing is I want to show you how basic carbohydrate metabolism works. Okay, the first main process is called glycolysis. Notice that, glucose is kind of built into that word. Okay, we're going to look at 10 enzyme reactions. Every one of them is catalyzed by certain enzymes. Now, we're going to go through these, and we're going to use our classification to name them all using our IUPAC enzyme classification chart. Not necessarily the official enzyme names. So I want to get you used to figuring out how these enzymes are named by looking at the processes by which they're undergoing. Now, we've mentioned this before. ATP, adenosine triphosphate, is the energy molecule. So when adenosine triphosphate loses one of its phosphates, it gives off a phosphate, and usually it's transferred. It doesn't usually end up in free solution. It's usually transferred to another molecule. Energy. So whenever the system needs energy, it has to take an ATP and convert it to ADP. In fact, ADP can go to AMP, the mono. Okay. So this glycolysis process is an energy generating process. It produces 2 ATPs. Now, this thing we haven't talked about at all. That is one of the molecules that is reduced, okay? So whenever we have NADH, it undergoes oxidation to NAD plus. And that gives off energy. So that's one way, another way I should say, of storing energy in NADH, the reduced form, and that's also called a coenzyme, or one of the many coenzymes, I should say. So there's 2 ways we can obtain energy: by ATP going to ADP and NADH going to NAD plus. So glycolysis is producing 2 energy molecules. Now, the thing about glycolysis is not very efficient at all. The third step in carbohydrate metabolism is where all the energy is produced, big time, like 28 ATP instead of 2. Now, simple organisms like yeast can't go any further. They end at glycolysis. So this is what they end up with. And that's the only thing they have to use for as an energy source, as ATP, 2 of them for each glucose molecule, and NADH. Now, when you make something that requires leavening, like bread, donuts, cake, sometimes you use yeast. And the yeast produces carbon dioxide. That carbon dioxide has air bubbles. Those carbon dioxide bubbles and the bread or cake you're making rises. Well, this is what does it, is the yeast feed upon the glucose and the sugar, and they produce this stuff here, giving off carbon dioxide in the process. Okay. Step number 1, glucose phosphorylation. Phosphorylation is an ester. Okay. Esters need 2 things: acid plus alcohol. So where the phosphorylation is going on, it's using Okay, so what's happening is that's carbon-6 there. So that's where the ester is formed of the phosphoric acid. So what we produce is we're going to take the phosphate group off of the ATP and transfer it there. So we're going to end up with that. Now, what is the enzyme that does that? Now, whenever you name enzymes, remember it's in two parts. First one is the substrate. So in this case, it's the substrate is glucose. And a kinase will transfer a phosphate group from one molecule to the other. So the phosphate molecule is coming from the adenosine triphosphate. And it's giving up the adenosine diphosphate. So if we look at our chart, where's our chart? Here it is. It's a go through here, and here's a kinase right here. So a transferase transfers functional groups, and there are two specific kinds. One transfers an amino group, the other transfers a phosphate group. So we have a transaminase and a kinase. So again, we have, that's the substrate. And this is the action. Transfers a phosphate group from one substrate to the other. Oh, and then to name this, this would be 6 if it's in the OChem version, it's going to be 6 phosphate glucose. The biochem version is glucose 6 phosphate. So the OChem, we always name the branch first. With biochem, we name the substrate first. Now, the official enzyme that does that is called a hexokinase. It's a very specific kind of kinase. Don't worry about that. That means hexokinase works on 6-membered ring sugars. Main thing I want you to know, it's a kinase. Kinases are very, very important because that's how we get the ATP to an ADP or an ADP to an ATP, the major energy molecule in our bodies. So this is what Okay, now what we're doing here is called a pathway. And we're in the world of biochemistry now. So reaction isn't a reaction, it's called a pathway. Just like reactant is not a reactant, it's a substrate. They just use different terms, which is kind of a pain, but anyway. Okay, so this is what we're looking at here. So we have planar glucose, carbon number 6, undergoes a transfer from the ATP to the ADP, and that ends up here on that carbon number 6. Okay, so the next thing is, it's called the isomerization of the glucose 6 to fructose 6. Okay, and that enzyme is going to be an isomerase, and this is the substrate. So isomerases just produce an isomer of the original substrate. So the substrate is glucose 6-phosphate, and that's the function. And so this is carbon 6 on fructose. What changed is this part right here. So when that glucose 6-phosphate opens up, it opens up to an aldehyde. Down here, when it opens up to a ketone. Okay, now we have the fructose phosphate. We're going to convert that and add another phosphate group on the other end of the fructose. So here's the fructose 6-phosphate. We're going to add through kinase again. So this would be a fructose So substrate is the fructose 6-phosphate, and that's the function. Okay, and the product is going to be so now we have 2 phosphates. So it's going to be, and it's on carbon number 1. So it's going to be a 1, 6. Now there's 2 ways to do this. Diphosphate, or in biochemistry world, they call it a bis, B-I-S, bis phosphate. And you can do it either way in here. Oops. Now, this is the name I want you to remember. Fructose 6-phosphate kinase. Now, specifically, it's a phosphofructokinase. That's the official enzyme. I want you to focus not on specificity like that. I want you to focus on what's the substrate, what's the enzymatic action happening on that substrate. In this case, it's a phosphate transfer, so that's a kinase. See, isn't this just like 305? Okay, so now we're taking that 2-phosphorus fructose, we're going to cleave it in half. And the reason why we had to add another phosphate group is because when we want to cleave it, we want each side to have a phosphate group on it. So we're basically splitting this, that bisphosphate into 2 molecules now. These guys here, these guys here. Notice when this is all said and done, each 3-carbon fraction has a phosphate on it. Now, there's an issue with the one on the left, the dihydroxyacetone, needs to be converted to glyceraldehyde as well. Because glyceraldehyde, this one here, is the only one that can proceed. So what happens is we have another step here that's going to convert it. Now, we're going to be using, remember the isomerase makes an isomer out of another substrate. So what we're going to do is we're going to use a isomerase to convert so this would be a dihydroxyacetone isomerase, converts it over the glyceraldehyde. Now, remember glycerol, we had the triglycerides during lipid stuff. So that's where the 3 carbons come in. Glycerol also has 3 carbons. So it's a triol though. In this case, we keep one of the hydroxyl groups in the middle. The one on the far right goes to an aldehyde. The one on the left forms an ester, is the remaining ester of the phosphate there. Okay, so let's go over this once again here. They're missing a step here. Okay, so step 5 only works on this guy here. So basically, what we need to do is convert in the bare sense, we want to make so we're converting that hydroxyl group to the aldehyde. Now remember how to do that? How do we do that in unit 2? Take a primary alcohol on the left there, primary alcohol. And what do we do to it to get to become an aldehyde? I know all of you remember this, right? I can see. We oxidize it. Remember? So this is an oxidation process. So that's an oxidase. So we're taking this guy here as a substrate. And this is basically an aldehyde. Excuse me, an aldehyde. Okay, it's an aldehyde. Alcohol. So the alcohol, boom. Well, an oxidase enzyme converts it to the aldehyde. Now, remember, aldehydes are very reactive. They're not very stable. So what happens is this guy here, the glyceraldehyde, wants to become more stable, and it does that by now, remember, one of the purposes of glycolysis is to produce ATP. This is the first step at which we produce ATP. So one thing we're doing here is we're going so, and where's this coming from? It's coming from the glyceraldehyde group. So it's going to lose its phosphate to ADP and produce an ATP molecule. So that's going to happen right here. So the first thing we need to do on this is to put another phosphate group on the glyceraldehyde. That's what this step 6 is. So first we isomerize this to that, and then both those now can undergo this phosphorylation reaction. Okay, so what's happening here is we are reducing the NAD plus to NADH. Remember, the two reasons for glycolysis is ATP and NADH. So here we're producing the ATP. Okay, so what's going on here? If this is being reduced, this has to be oxidized, right? So we're taking the aldehyde here, and it's going to the acid, which ends up being ester. Just like before in Unit 2, we're taking an aldehyde, actually it's Unit 3, we're taking an aldehyde, oxidizing it, taking it to the acid. Okay, so whenever something's oxidized, something has to be reduced. So that's what's happening here. So it's gaining an H, reduction. It loses an H, it's oxidation. Okay, the next part of that is going to be, we're going to be losing that, putting it on an ADP to become ATP. So those are the two energy steps in glycolysis. This one here creating the NADH. Second one is creating an ATP. Okay, so notice we're left with the acid now. So just like in unit 2, unit 3, the aldehydes oxidize to the acid. In our body, frequently we do multiple steps, not directly, because we can do it slowly. We can also control it better or regulate it better. Let's see here. Okay, so here we have the acid. And what we're going to do is now we're going to phosphorylate, bless you. That phosphate group is going to go over to the next carbon over. Okay, and that's called a mutase. So the substrate is, well, this would be the substrate. And all we've done is just moved the phosphate ester one carbon over. So we've mutated. We didn't transfer now. We just, on the same molecule, we move the phosphate from carbon number 3 to carbon number 2. Now, what we're going to do is we're going to convert this guy and pull water off. Now remember, how do you create an alkene? One way is with an alcohol. We pull water off that molecule and recreate a double bond or an alkene. That's what we're doing here. So this is the alkene. So we're taking an alcohol, converting it to an alkene plus water. So in that alcohol, you've got to have an OH and an H present on adjacent carbons. So what we do now is we're going to convert this guy into a carbonyl group. Okay, and then we have the second ATP form. So this is going to be that's the substrate kinase. And that's happening right here. So we're at pyruvate. Pyruvate is one of the 3 carbon molecules you produce out of glycolysis. And then there's one more step where we go to an acetyl-CoA. So this is the results of glycolysis. We're producing pyruvate, 2 of them. We're producing 2 ATPs and 2 NADHs. Okay. So there's one more thing. Let's see, where are we here? Now, there are 2 other sugars that can enter the glycolysis cycle. That's galactose and fructose. you don't see mannose too much. These are the two main ones. Okay, where they come in, where they come in is step where the glucose, the 6-phosphoglucose is converted to fructose, and that's where the fructose comes in. Same with the galactose. The galactose comes in a little higher than the fructose. Okay, so what happens to the pyruvate now? It depends on what you are. Are you a yeast? Are you a mammal? If you're yeast, you stop there basically. And you use that, and then you go on to produce ethanol and carbon dioxide if you're a yeast. Now, an intermediate step between glycolysis and the Krebs cycle is converting pyruvate to acetyl-CoA. So if you can somehow create acetyl-CoA by burning fats, by burning glucose, or burning amino acids, then you can enter the Krebs cycle. So here we have pyruvate. Here's good old yeast. Yeast does not need oxygen. That's why it's called anaerobic. Goes from pyruvate to ethanol. Pyruvate converts to lactate. Notice anaerobic muscles. What happens when you're exercising? What happens to your muscle after a while? It starts to hurt, doesn't it? Okay. That's because you're not getting enough oxygen to that muscle. And we're under anaerobic conditions, so we produce lactate or lactic acid, and that's what hurts in your muscle, the lactic acid. So if we have adequate oxygen, it's called aerobic. So there's two conditions. We're going to take that pyruvate. No oxygen, that produces the lactic acid, salt or lactate. If we have adequate oxygen, in other words, we're fit, we're going to produce the acetyl-CoA. Now, on Tuesday, we're going to start with acetyl-CoA in the Krebs cycle. And there are more steps in the Krebs cycle in the glycolysis. Okay, so what I want you to do in this glycolysis is to go through each step and make sure you understand what's going on. Secondly, the generic term of the enzyme that creates that new molecule. Okay, we're going to do the same thing with the Krebs cycle. Krebs cycle is longer than glycolysis, like I was saying a few seconds ago, but it's similar stuff. Now, that S is a thiol. So this is a SH here with a ester to this guy here. This is a rather large molecule. Okay, so this is where we are right here. We just made acetyl-CoA. So when we go into the Krebs cycle or citric acid cycle, keep changing the name, we're going to end up making more ATP, more NADH, and something related to NADH is FADH. And then this is the important step here, electron transport. That's where all the majority of energy is created from the mammalian energy cycle. So through our evolutionary process, we've been able to really maximize the amount of energy we produce in the form of ATP storage. So if you're a little guy, like a little yeast, you basically stop here. Mammals continue on. Now, for your final, it's going to include Unit 5 and a smattering of the others. Just a smattering, very simple reactions. You may have a 3x5 card, like also you may have that enzyme table. Okay, so that's what I wanted to cover today, glycolysis.